It's been 3 or 4 months since I've completed the machine and have been using it to try out different projects. The entire build took me about 4 months, maybe a little bit less. I worked on it almost, I'd say 5 days a week in the evenings, so I worked pretty consistently on it. I thought what I would do is, now that I've got some time and can a little bit of perspective, go back and add up how much it cost me to build this machine and show some of the choices that I made that drove that cost, and maybe some of the things that I would do differently if I were to do it again. So the bottom line is, this machine cost me $8,000. My budget was $7,000 and I did go over. The good news is you don't have to spend $8,000 if you don't want to, and I'm going to show you the big ticket items that drove some of that cost. So you can see from this list that just these big ticket items cost me $6,500 total. So out of $8,000 to build the machine, this was the bulk of the expense. And then there's nuts and bolts and tubes and all the incidental things that you also need to purchase along the way. So the 80/20 is the aluminum extrusion. That actually wasn't that expensive, I thought, for $370. You might be able to do better on that, but I wasn't unhappy with $375. The carriage plates, so the X and the Y carriage plates, I had those built for me. So I bought my plans from joescnc.com for $75, and for $565, Joe will mill the aluminum plates for you. You don't have to have him do it. Having built the machine, I feel pretty confident I could do that myself. I do understand the aluminum stock is very expensive, so you'd have to figure out just how much money you would save and whether it's worth it to you. I wouldn't be too intimidated by it. When I first started this project, I would never even consider doing something like that. But aluminum is actually pretty easy to work with, so that's quite doable. But you'd have to see if it's worth it given the cost savings. So my machine is a rack and pinion driven machine. The drives, so the drives that the motors mount onto to take the pinion, I bought from CNC Router Parts, and they cost $480. That was expensive. The gear racks that you use to engage the drives was $225. The Z-axis, so this mechanism that allows the Z-axis to move up and down, was $430. That was expensive. I don't know what option you would have there, though. I suppose you could build one yourself, but that's pretty advanced. The NEMA 34 kit, so I've mentioned this in my other videos, I bought a complete electronics kit. So this was the controller, all the controllers, the drivers, the box, the power supply, and 4 NEMA 34 motors for $2,600. You could definitely save money here. I have no need for NEMA 34 motors. NEMA 23s would have been fine. After 3 or 4 months, I haven't run into any case where I really need or even could use the power of the NEMA 34s. My machine is pretty rigid, but I don't really feel like I could push it much beyond what a NEMA 23 could do for me. The cost differential just for those motors was $1,000, and then if you're good with electronics, you can come in less than whatever it would be, $1,500, $1,600, or the $2,600. Again, when I started the project, it's not something I would have considered. I was too intimidated by it. Having done the project, I definitely could tackle that piece of it. Whether I would or not, if I were building another machine, I'm not sure, because again, the components are not cheap, so you have to do your research to see if you can really save money. And then, knowing me, I'm always buying the wrong part and finding out through trial and error. So by the time I ended up with the kit that I need, I might actually spend more than the pre-configured kit. And by the way, this just makes your life so much easier. Everything works, just plug and play. So for me, that was I would not spend the $2,600 again, but I would probably buy the kit, and I would buy the NEMA 23 motors. The spindle and the VFD, $310. This was one of the best bargains of the whole build. So I have my 2.2 kilowatt water-cooled spindle and the VFD that came with it for $310 off of eBay. I don't think you could beat that. A good router would cost you that, and I've had really good experience with it. I would definitely do that again. The software, so I was a little naive. I had no idea I was going to have to spend $920 on software. So I bought Mach 3 to control the machine and VCarve to do the design. So that was almost $1,000. You certainly don't need VCarve, but you do need something like Mach 3. So there is some potential savings there. It really depends on what you want to do. I need VCarve for the kind of things that I like to do. So for me, it was a necessity, but you may not need it. You can do some other research on what other software is out there. I don't really know. There may be some open source. I'm not sure. And I bought a brand new computer. Certainly didn't need to buy a brand new computer. I could have bought one for... Actually, I did originally start out with buying one, a refurbished one off of Amazon, a Windows XP machine, which was fine. It was less than $100 with the monitor. The reason I decided to buy a new computer was because I didn't want to run... I had two computers, one for Mach 3 and one for VCarve, and that was a pain in the neck. So I wanted one machine that was powerful enough to run both of those. And then $75 for the plans from Joe CNC. Well worth that $75. I don't think I would have been able to build this machine. Now it's planned, but it's not a how-to guide. It's more of a really good 3D rendering of the machine and how everything goes together. The forum that you get access to for this $75 is invaluable. That's where I had all my problems solved and all the things I came up against that I didn't know how to do. There was always somebody who was ready and willing to help and had the expertise to solve my problem. And whatever problem I came up with, they've seen it before. So that was invaluable to me. You could definitely build a machine without plans. For me, $75 was really worth it. Also, you get things like, it's all in the forum, but for example, I'm not posting my whole bill of materials here. I downloaded a bill of materials from one of the forum members who put together just a really nice detailed bill of materials, where he got everything, how much everything cost, and that alone was practically worth the price of the plan. Plus the 3D rendering really helps you. You can pull parts apart. You can focus in on holes and tap sizes and everything. So really worthwhile in my opinion. Now, so where did that other $1,500 come from? I'm just going to take a quick walk around the machine and show you a few things. And you can imagine this is just where every little thing adds up, and some of these things are not inexpensive. This dust shoe, this is from a guy called Kent's Dust Shoe. Oh, look, there's a screw in there. It was $150, but boy, I can't imagine running this machine without the dust shoe. It really allows your vacuum to work and keeps the dust, at least within this area. Otherwise, you really make a mess. Just this hose alone, I forget what I spent for it. Then I bought this PC water cooling system. That's the pump and the reservoir. And in the back, you can see this little radiator. Altogether, it cost me, I think, $60 for the pump and the radiator. I bought this, what do they call this? I think they call this E-Track for cable management. There's a variety of qualities and costs for these things. Actually, these are two different qualities. The one on the Z-axis is a nicer quality brand, but I didn't want to spend that much money on all of this track just to run wires. So, but that was not inexpensive. I forget how much it costs. Here's where I really went cheap. This tray here is a stud for drywall. This aluminum stud works just fine, but it's got really sharp edges, so I have to do something, so I stopped cutting myself. There's the electronics kit that I spent $2,600 on. It was soup to nuts contained, so again, I thought that was worth it. But you could go ahead and buy the $1,500 version and go with the NEMA 23s, and I don't think you'll ever be sorry. And then, as you can see, I built a wooden base out of 2x4s, 2x6s. I'm sure that's $300 or $400 worth of wood there. Then you have the angle iron I used not just for holding down the axes, but I use the angle iron for my bearing tracks. They work just fine. This is a place where I actually chose to save some money. There are nicer options. You can buy hardened V-rail. You can also, now they have these high wind track systems that are really almost friction free. This is an upgrade that I would consider doing, and something I left for a future upgrade. To tell you the truth, I'm not sure I need to. It really goes to what kind of work you're doing. I just work with wood, and the precision I would get from better rails, I'm not sure it would ever make a difference in the kind of work I do, but I'll figure that out with more experience. You may recognize this as a collection of broken CNC spindle bits. So I remember early on I was naive and I was thinking, gosh, how do you sharpen these bits? When these bits get dull, it must be really challenging to figure out how to sharpen them. Well, I have not had the pleasure of dulling a bit yet. I've broken all these bits and more. 99% of the time it was my own fault through moving the machine when the Z was at the wrong axis or not using the software correctly. Anyway, the suggestion here is buy some cheap bits. You're going to break them. I've broken some expensive bits, and I learned early on that I don't need to worry about quality until I learn how to use the machine, and this is an expensive way to learn. So get yourself some really inexpensive bits, and you won't pull your hair out when you break them. So from that short overview, I think you can probably see how I easily spent $8,000 on this machine, and hopefully you can take this information and make some choices for yourself on where you want to spend your money, and if you want to build a less expensive machine, what choices you can make to get there.